Today, we're diving into some really fascinating new evidence that tackles a question you've probably wondered about. Does a warming planet actually make you more likely to get food poisoning? Well, a recent study put some hard numbers to this idea for the very first time, and frankly, the findings are a big deal for public health. So let's break down the research. It just kind of makes sense, right? We've all been warned about leaving the potato salad out at a summer barbecue. But that feeling, that intuition, well, it isn't data. And to get beyond just stories and guesswork, researchers in Australia decided to dig into 15 years of public health records to see if they could measure the real connection. So why do a whole study on this? Well, it's because while we know bacteria multiply faster when it's warm, we've never really had a clear picture of the total health burden. How big is the problem, really? Without knowing the scale of it, it's pretty much impossible for health officials to plan for what's coming with climate change.
Right, so we've known forever that nasty foodborne bacteria like Salmonella and Campylobacter absolutely thrive in the heat. That's just microbiology 101. But the big missing piece of the puzzle was being able to quantify that risk across a whole population. How many more people get sick when the temperature goes up by 1 degree? And the really big question, what can we expect as the world keeps getting warmer? And that is exactly where this new research, published in the Lancet Planetary Health, comes into play. For the first time, a study has put actual concrete numbers on the health problems caused by these infections that can be tied directly to temperature. They looked at an entire country, Australia, and then projected that risk into the coming decades. So, to get these numbers, the researchers used a pretty sophisticated multi-step approach. Let's walk through how they actually connected the dots between the weather outside and people getting sick. First, they pulled together a massive amount of data. We're talking 15 years of health records on Salmonella and Campylobacter cases, matched up with daily temperature data from all across the country. Then they used this fancy statistical tool called a meta-regression model, which is basically a way to combine data from lots of different places to find one consistent pattern. This let them calculate exactly how much the risk goes up for every single degree Celsius the temperature rises. And finally, they plugged that number into 2 different climate change scenarios to see what the future might look like.
Now, a key term you need to know is something called a DALY, or a disability-adjusted life year. Think of it as a currency for measuring the impact of a disease. It's a standard public health tool that combines the years of life someone might lose from dying early, plus the years they might spend being sick or disabled. So 1 DALY equals 1 lost year of healthy life. It's a really powerful way to capture the total impact.
So, to look into the future, they used 2 standard climate models. Think of them as 2 different paths we could go down. The first is called RCP 4.5. That's a medium emissions path, where we take some action and emissions start to level off. They compared that with RCP 8.5, which is basically the business as usual path, a future with continued high emissions. Using both helps us see how our choices on a global scale might actually affect our health.
Okay, so after all that math and all that modeling, what did they actually find? Well, the results show a really clear and measurable impact that is already happening right now.
Let's start with Salmonella. The study found that between 2003 and 2018, a full 11% of the entire disease burden from Salmonella infections in Australia could be directly blamed on the ambient temperature. And for Campylobacter, the other big bacterial culprit, it's a very similar story. They found that 8% of the total health burden from that bug over the same period was linked to warmer weather. Now, the really crucial point here is that this is not some far-off future problem. These percentages represent a real existing health issue, people getting sick, having to miss work, and in some cases dealing with long-term health problems, all connected to the climate we're living in today. And of course, this leads to the million-dollar question. If this is the impact we're already seeing, what happens next as temperatures keep climbing? Let's take a look at the study's projections. Okay, check out this chart. It really tells the story for Salmonella. That first bar on the left, that's the baseline burden we've been seeing. Now look at that middle bar. That's the projection for the 2050s if we stay on that high emissions path. The health burden more than doubles. But, and this is so important, look at the third bar. It shows that if we just get 10% better at adapting, things like improved food safety, we could actually make a serious dent in that future risk. It's also really important to know that this risk isn't spread out evenly. The study found that the hotter, more humid parts of the country, we're talking tropical and subtropical areas like Queensland and the Northern Territory, they already have the biggest problem and they're facing the greatest risks in the future. This really highlights that one-size-fits-all solutions probably won't work. So, we've got the data. we've got the projections. What does this all actually mean for us, for our families, and for the people running our healthcare systems?
This kind of research is so critical because it shifts the conversation. It's not just about you being careful with your picnic basket anymore. It provides the hard evidence that leaders and policymakers need to say, hey, we need to invest in building public health systems that can handle a warmer world. It's about systemic preparation, not just personal precautions.
And what does that kind of preparation even look like? Well, the study points to some really concrete ideas. Things like stronger food safety standards, creating systems that track weather data and disease outbreaks together, and running public education campaigns. And I think this is really smart. Developing early warning systems that could alert everyone, from big food companies to us at home, when we're heading into a high-risk weather period.
Okay, let's zoom out for a second and look at the big picture. Like any really good piece of science, this study is upfront about its limitations, and understanding them helps us see just how clear and powerful its main takeaway really is. So, to be totally transparent, this study doesn't answer every single question. The researchers focused only on temperature, not other things like rainfall or humidity, which probably play a role too. They also had to assume that any adaptation measures would be applied the same everywhere, which might not happen in the real world. And of course, at the end of the day, these are models. They're powerful, data-driven projections, but they're still projections, not a crystal ball. But even with all of that in mind, the bottom line is absolutely unambiguous. This research gives us some of the clearest evidence we've ever had that climate change isn't some abstract threat in the distant future. It is measurably impacting our health right here, right now, and that impact is on a clear path to get worse.
And so, what's the final message? I think it's best to leave the last word to the researchers themselves. They conclude that their work underscores the necessity for targeted public health interventions and region-specific climate adaptation strategies. In other words, the evidence is on the table. The real question now is, what are we going to do with it?